above the rest. So thank you for, I believe that's it. That's our class. Thank you for everything. If there's any other questions, we can go over them. We can go back and look at another slide. Yeah.
I got a question that Chris and I spoke about a while back. Why does load calculation JS&D software calculate variable friction rates?
I know Russ does. There's a box you can check to do a variable friction rate. And I can't speak for it. I don't know if Russ King.
Russ is here.
Yeah, Russ is here. I don't know if he's active on the. There you go, Russ.
Why would it not be beneficial if you're doing it longhand to do a variable friction rate? Simply because it takes too much time?
I'm going to let some of these guys that are a little smarter than I am answer that.
I think
maybe. Oh, go ahead.
I think doing it a variable friction rate by hand may be super cumbersome. That's a hell of a math equation. I think you have to have software to do that, in my opinion. What do you say, Russ?
Yeah, I think the old worst case comes from back before we had software. Now that we have software, it's super easy to let the software calculate a friction rate for each individual run.
Yeah.
And if you look at, say, Tim, you look at your layout and you look at the shortest run and you look at the longest run, and imagine those two runs needed the same CFM. What you're saying is they need the same size duct. And that's probably not the case. I mean, it does take a lot of equivalent lengths to change a duct size, but there are times where you have a really short run that needs 100 CFM, and that needs one size duct, and a really, really long run that needs 100 CFM, that's going to need a different size duct. And the only way to account for that is a variable friction rate. And it's super easy to do with the software. So that's what I always have done. So
now, from a Manual D standpoint, because we were doing this, on the speed sheet, and that's why I didn't cover it. I always check the box and like writes off, but is there a way to do it longhand with Manual D? Is that even possible? Or because I've never seen a variable friction rate in the Manual D process.
Yeah.
In the book.
Maybe in there, but
you'd have to look at each register and take it all the way from the register all the way back to the return grill and calculate the equivalent lengths for every
pretty much doing that whole process that we did for TEL for times 20 if you have 20 supplies. Yeah.
Right. But the software does it pretty much instantly.
Right. Because it is true. Like in my living room, I've got two 8-inch that dump air into my living room, and I've got them specifically sized to go up the peak of the cathedral ceiling where my ceiling fan catches it and sort of my ceiling fan always just kind of rotates. So all I'm trying to do, I'm not trying to throw air to the other side of the room, just trying to throw it to the peak. But when I installed everything, it was with all my dampers wide open. And I had an imbalance. In fact, my static pressure was like less than 0.2 inches total static pressure, like less than 0.1 inch. But I was really cold in the living room. The air wasn't getting anywhere else. So once I throttled them back, static pressure came up a little bit. And so I probably could have gotten away with a 6-inch, but the software told me 8-inch, and who was I to argue with it? So, but yeah, you're absolutely right. There are a lot of cases, and that's why we put dampers in systems, because it's really easy to add friction. It's really hard to take friction away after it's been installed. Is that accurate, Russ, Chris?
Very much. Yeah, absolutely.
Okay. Yeah. Yeah. Great question. I'm going to go grab a beer. You guys are welcome to grab a beer and come back and pop a top, and we can tell some more war stories and ask some questions. But give me just a second. It's been a long day for me.
Same here, dude. I'm still working.
We're way ahead of y'all.
Oh, yeah?
I was talking to Alex Meany about because on writes off, there's like a magic button you have to hit to be able to access a variable friction rate. It doesn't just show up, I think. There's like a control sign. I don't remember what it is. But his explanation to me was that it keeps people from making mistakes before they understand what they're actually doing. because a lot of times if you have a friction rate and you check that box, you may be at a 0.06, and then you check that box, and then you're back to a 0.1. So it's I guess what they put in the software to keep people from making mistakes, or at least that's how he explained it to me.
Hey there. I'm surprised I haven't heard anything about a hot wire anemometer. Is that what it is? A hot wire thing?
Yeah, I probably should have put that in there. I was kind of putting in slides at the very end. I wasn't going to get this much into diagnostics, but I ended up doing it. But yeah, you're right. That's a good suggestion. I should put that in there. You know, a hot wire anemometer is, I guess you can use it on trunk also. You know, there's traversing of the duct that would probably need to happen, right? And then you got your regular pinwheel anemometer that you would use for supplies. But there's some room for error for those, right? I mean, I used to air balance with a pinwheel anemometer, and it was really hard for me to get consistent results that I could actually trust.
Right. I figured that there's probably better stuff now than a hot wire. And also I've got one of those CPS pinwheel things that Bluetooth in it. And it's, you know, depending on where you hold it, you'll get different results. But, you know, I use it to get an average or, you know, an idea.
Yeah, I mean, like you got a 90 boot that's under a floor, and you can hold that little anemometer in one place, and it's spinning like a top because that's where all the air is coming out of it. And then when you hold it closer to the inner part of the 90, the inner throat, it might even spin backwards. And it's like, what do you do with that information when the thing, you know, if you wanted higher airflow, you kind of hover over the part of the boot that it's spinning faster with. I mean, there's so much room for error there. I don't know.
Right.
Anemometers are great when you have an answer that you want to get.
Yeah.
Yeah. When I was with the HERS Raider, a lot of times, you know, it'd be like, uh-oh, I need a little more air out of this boot. Let me hover around the better part of the boot a little bit more. No,
I would say I would add this piece of info that I've learned since I've been at TEC. So just full frontal, like I've been in trade my whole life. And then the last 2 years I've worked for TEC, strictly working underneath engineers. And here's what I've learned. You really got to read the specs of tools. Like you got to get in and read the super nitty gritty details. And once you start reading into the details, it's amazing how many products are on the market that appear that they can take all these measurements until you read the fine print, right? Just because it pops up a number doesn't necessarily mean the number doesn't have some good literature that says, oh, it's accurate at full scale or accurate at partial scale. And it's like, what the hell does that even mean? Right? I've had to go to my bosses and be like, what does that even mean? Like partial scale, full scale, like what are they getting at? Until like Steve broke it down for me, I'm like, well, shit, that means this measurement doesn't even really matter. And he's like, yeah, exactly. He's like, but it wouldn't sell tools if that's what it said, you know?
Yeah.
It's pretty wild that's the world we live in, you know?
Now, I remember years ago, I bought a manometer because it had more numbers behind the decimal point than the other one on the shelf. Doesn't mean those numbers were accurate. We talked about that. It was a random number generator. It was just a better random number. It just generated more numbers randomly. But yeah, you're absolutely right. And that's why it's like having a community like we have here where we know that anything that comes out of TEC is going to be high quality. We know it's going to be, we just know to trust certain tools because they're not going to sell us crap. Whereas if we don't have a community where we know the people that are developing this, you just don't know. You'd have to read the nitty gritty specs, and who are going to do that? It's a wild west out there. So
I have been using the field piece manometer, and it's been fairly good to me, and it has helped me to diagnose and fix some airflow issues in the past.
absolutely, I used one for years. It was that one that I bought. But when I compared it against a micro manometer, I realized when you're reading things like pascals, mine was not accurate in the Pascal range. It was great for reading static pressure on units. It was great for reading certainly manifold pressure on furnaces, but there's limitations. You know, that thing's also going to bounce around in the tool bag a lot better than some of the micromanometers out there that may get out of calibration when, you know, your tool bag gets air mailed off a roof accidentally because your helper did tie a good enough knot when he's lowering your tool bag off the roof. You know, there's certain tools that are going to stand up to that a little bit better. So there's a trade-off, you know.
There's a need for both, to be honest with you. There's
Yep.
just a need for both. There's a time to dig out your micromanometer, and there's a time to dig out your $100 basic manometer. There's a time for both of them.
Mhm.
If you're going to check backdrafting, or if you're going to go do dominant duct leakage testing, which is kind of another level we don't have to get into in this, but there's like, man, 14 tests to a house I could think of that you could do to test a house with a micromanometer that you can't do with a basic manometer. But at the same time, there might be something I wouldn't want you doing with a micromanometer. You know what I mean? And we have a range. Like, I'll tell you, I've checked into our sensor technology that we use for our micromanometer because I really wanted to say you could use it to measure like propane, but I think our sensor stops at like 10 inches of water column, I believe. And I think propane, you got to be between like 13, 15. So you can't use it on that. So that's the one use case I get, you know, I kick myself in the butt and be like, man, I wish we could get a sensor range that'd be a little higher than I could say it's all purpose, but it's just not. It's just not. You can't get that caliber of sensor to meet that full scale.
Yeah, the DG8 is just it's so compact too. It's like, because the other micromanometers are a lot larger.
Oh yeah, we sell one, man.
Yeah.
It's like 3 times the cost of the DG8.
Right. But I just like the small size of it also. So
Yeah.
Yeah. So it's like, it's one of those things where you may not be able to buy all these tools tomorrow, but like any other tool list, it just needs to be in your wish list. And maybe it needs to get bumped up the list a little bit, hopefully after this class, especially with that coupon code.
And I'll
There's
just
a long wish list in this trade.
Yeah.
Another price.
Spend all my money on tools.
Yeah.
Yeah.
And I just want to reiterate what you were saying, Tim. Like, look, I'm not going to be the first one to bash to say, like, look, here's the thing. If what you have is a manometer, you got to start somewhere. And that's the place to start. If that's what you got in the tool bag, use that bad boy and start taking pressure measurements, go into the blower charts and start there. Like, that's a great place to start. You know?
Yeah. I mean,
A few questions.
yep.
Yeah, static pressures. Yeah, those have become important to me. Measuring, because I have found that, you know, static pressure is sky high on some units, and I absolutely do believe it was the reason why the compressor went out. I mean, it's safe to say that poor airflow or restricted or supply vents being closed everywhere except for one because they want to push all the air to one room, that can contribute to killing a compressor. Is that right?
Well, the compressor doesn't really care about all the airflow going to one room, but the total airflow across the evaporator coil is probably the unintended consequence that
Right.
the compressor is seeing, because it's flooding out.
The return air is messing with the compressor.
Yeah, it's just not getting air across the evaporator coil, so the evaporator is not getting the heat it should need, and so your refrigerant isn't boiling up. So you're sending liquid refrigerant to the compressor.
Right. Another thing, let's see. I hate it when I find this. The return air duct is just, the gas furnace has just got a hole cut into the furnace itself.
Yep.
And right above, and the return air duct is installed right above the blower.
Yeah.
I mean, that can't be good for airflow.
Right. No, it really isn't. Really anything above 3 ton, you need to either be pulling from both sides of the furnace or the side and the bottom. If you got a side return on a 3.5 ton unit, or a furnace is moving 1400 ish CFMs, that's not enough of an opening to a furnace. You've got to pull from both. But definitely the 14-inch hole that's cut inside the furnace. Yeah, that's bad news.
Yeah, or on top, it just looks bad, and you destroyed. I'd like to see a return plenum installed,
Right.
but my gripe is that I point all these things out to owners, and I give them a quote, and they're like, I can't do that.
Yeah.
Yeah,
And,
but you documented it, which is saving you from it's
Right.
documentation's key, man. Like my time of the trade, every time I could write something down and then go back to it when that customer would have a complaint, and I could say, hey, look, I quoted you on this. It's not my fault.
Absolutely.
Like, I did my service. I gave you the option to do more. You
Yep.
chose not to. This is on you. I hate to be the person. I'm not that guy to say like I won't warranty my work, but at the same time,
Right.
if there's negligence and you can prove it, then you're not warranting work.
yep.
No, I've absolutely become very anal about writing all that down. Definitely.
Yep.
Quick question. I mean, I'm in the Houston area. We don't use our heaters much. And this is my last one. Combustion analyzer versus just running the heat for about 15 minutes and using a field piece CO detector and just, putting it against the supply vents, and just testing to see if I can't detect any CO that way versus what I've seen before, combustion analyzers, where I guess there are more up north where people depend on heat to live, where it might need more thorough testing, where you're punching a hole through the flue. I mean, am I okay to a degree with just simply running a CO field piece detector and running the heat for 15 minutes, and if I don't get any blips, I'm good?
Well,
Yeah, babe, would you?
Go
I
ahead,
love
Chris.
you. Oh, I do love you so much.
Are you asking? There's two questions kind of embedded into one here. Are you saying you're trying to protect them from CO poisoning, or are you trying to commission the furnace to make sure it's working right?
Well, during a heat inspection, I'll run around with the CO detector, while it's heating,
Mm-hmm.
and just to make sure that it's not emitting any CO
Yeah.
while the heater's running.
Here's what this is my just feedback, and I'll be the first one to tell you combustion is not my strong suit, but I've learned a lot sitting in the NCI class. Luckily, and I've only lucked out from this. I've gotten to sit in that class a few times through to the relationships we have with NCI. So David's always like, hey, you want to sit in? I'm like, yeah. So I soak like a sponge when I go sit in that class. And it's amazing how much thought goes into a combustion analyzation test with that tool, and what you can pay attention to and what you can find out with like a solid, 20 minutes of the combustion analyzer running it. And I know that sounds like a lot of time on a job, 20 minutes of looking at combustion, but their research on combustion is next level and amazing. And there's situations where a furnace runs, and then after so many minutes of runtime, the numbers will then begin to change, and that's when problems show up. And you can pick that apart in their combustion class. Like if you ever sit through NCI's combustion class, they will walk you through how watching they have tables on all this and exercises in their booklet, and it says, furnace ran for 15 minutes. These are the numbers. The next 10 minutes, the numbers went to this. What happened? And they walk you through that problem. And I was like, whoa, because I had never done that in my life. Like I'm learning something new when I sit in that class. I'm like, whoa, like that's next level stuff. That's how much they know about combustion. Like in my mind, they're the all-stars of the combustion game.
Yeah.
Is combustion analysis a requirement for commissioning by the manufacturer?
Oh, good question.
According to ACA, it's considered a standard of care.
Yeah. I don't think it's I don't know. I'd be lying if I told you I knew the
Yeah,
answer to
I
that.
don't know the answer off the top of my head. I will say that you're doing half of the test, so you're doing better than someone that's doing none of the test. You're at least trying to protect the customers from CO that day when you're there. The combustion analysis also tells you how much CO is in the flue pipe, and that CO can tell you whether you've got a bad or the oxygen. If you got too much oxygen in the flue pipe, it can tell you that you've got a ruptured heat exchanger. It was something that you may not even see visually, and you may not even see it with the with testing for CO in the supply duct. Because think about it, where is a heat exchanger on a typical furnace? It's on the return intake. So if you get a hole in your heat exchanger of anything, you're actually going to be sucking oxygen into the heat exchanger, not spewing CO out. Doesn't mean that CO is not going to get back into the house, but there is a lot more reasons for checking combustion analysis other than just occupant safety. If your system is blowing out a bunch of CO out of the flue pipe, that CO can make its way back into the house through openings in the house. You don't want a lot of CO in your flue pipe. It means it's not burning clean. It's reducing the life of the furnace. So there's a lot of things there that you're leaving on the table. With that said, when we used to, like in Greensboro, we were 50% gas, 50% heat pumps. Once we set up and commissioned the furnace, we didn't go back and do a carbon monoxide or a combustion analysis every year until the unit got to about 5 years old. It was just not something that we did, but definitely on older equipment, that was something that we did every time, because it would, I mean, you would find heat exchangers, you'd find all kinds of problems, overfired furnaces. We found a lot of overfired furnaces.
What do you do with that?
Well, it depends on what you find. So if you find an overfired furnace, the first thing you're going to do is check manifold pressure.
Let's say manifold pressure's on.
Change nozzles. It changed nozzles because it could have come with the wrong nozzle. They could have done a propane conversion kit but not put in the nozzles. They could have. I mean, there's a lot of things that can happen with that. So again, it's not only occupant safety, but it's also equipment. You know, you're trying to protect the equipment. So I would say that it is important. It's something we started doing. We were probably the only company in Greensboro doing combustion analysis on PMs, residential. It's just something that we did in commercial industrial, and I just carried it over when I started my business in residential. But I get it. A 2-year-old furnace, probably, you're not going to find a lot of problems in a 2-year-old furnace.
I've simply never done it before, because I was always of the mentality, why would I want to know all this data when I only have gas pressure to mess with? And the manual says I set gas pressure to X. I set it to X. I have nothing else. I can't do anything else with it.
Right. Yeah, that's the thing about a furnace. You can only adjust gas pressure and airflow.
Yeah.
You know, the older furnaces, you could adjust the little primary air and secondary air shutters, and you could really fine tune that thing like a big boiler. But they took all that away from us. But I could tell you how many 20-year-old, 15-year-old furnaces that I found with a cracked heat exchanger, and the only way that my technician found it was some really funky readings on the combustion analysis. And then when we finally pulled the furnace, we looked inside, and sure enough, and it is a condensing furnace where you can't even see the primary heat exchanger on a condensing furnace. You can't see past the secondary.
Are you going to see other symptoms of a cracked heat exchanger before it? Let's say you don't do a combustion analysis. You're going to get rollout or something visual is going to happen that you're going to pick up on that without doing the combustion analysis.
The colors of the flames, maybe.
Maybe not. It's the
I can touch
combustion
on this a little bit.
Yeah, it's you may or you may not. I mean, like I said, we found furnaces with bad heat exchangers that the only way that we found it was because we did the combustion analysis. None of the other items, the flame color, the checking the flame color when the blower turns off, you know, that's sort of looking for that little flicker. Nothing else happened. It was because it was running 1,000 parts per million CO in in the flue, and the technician even backed it down to 2 inches of water column, and it did not make a difference. The other thing that it's going to find, and you may find this with flame color, it'll catch impingement, flame impingement against the heat exchanger, because you're going to run a high CO because the flame is hitting the side of the heat exchanger, and you see some orange tips in a flame. Is it normal? Is it not? Some technicians are just going to walk away from that, but that carbon monoxide test in the flue is going to pick it up.
One thing that I was pushing towards the end of my full-blown AC career, which was over some time back, any furnace I sold, I included a low-level defender.
Oh yeah, that should be standard operating procedure, but unfortunately it's not. So good for you, man.
Also, how the hell did we get on combustion? This is supposed to be a manual D Duct.
Yeah.
Yeah, I've had these questions for a long time, and I was
That's all
waiting
right.
for an opportunity.
That's all right.
That's what you do during beer 30.
Hey
Right.
Tim, are you just gonna email us the stuff?
Yeah. So it'll. We're still recording right now because some of these questions are really good. So this will be in the recording, and then it'll get emailed tomorrow. It takes hours to process this video for some reason. So what you'll get is an email with a link to YouTube, but it is a private link to YouTube. It's not something someone else can pick up. But I've got to edit out the top secret stuff that Chris presented first. So that'll happen tomorrow.
All right, cool. Appreciate it.
Did you guys see the, go ahead, I didn't mean to cut you off.
Well, the last thing I just want to say before people start signing off, and I just want to make sure I catch it in the recording, please go on Google. I'll try to send you a link also. Leave my company a review about the training portion of it. This is how I earn a living. So the company is Comfort Science Solutions. I'll make sure I include a link in the email. Please just give me a 5-star because I'm also trying to market to local HVAC companies here. And this helps me, this helps my company. It helps me gain company rankings when somebody needs a service call and that sort of thing too. So just please leave me a review. But I'll leave you a link in the email also. Just please take a moment and do that.
I need to correct my statement because I don't want to make Alex Mini look bad. It's not the variable friction rate, it's the velocity adjustment for the equivalent length that is the magic button in there. So
Alex Mina will kick your ass next time he sees you.
yeah, I said, well,
I don't think I caught
Alex
it.
ever sees this. I don't want it to say, man, I didn't tell that dude that.
Yeah.
I want to say the variable friction rate is probably, Russ could maybe speak on this, but that's probably a standard option, I would imagine.
I think it is.
Yeah,
It is.
but the velocity showing, are you saying like a secret toggle button to show the velocities?
Yeah.
Like it will show you the velocities per duct, so you can then manually change them?
It doesn't manually change. You'd have to ask Alex exactly how. 'Cause he told me there's like a control 0 or something that you hit, and it gives you this option. But it doesn't come standard. You have to actually. So I put it on when he gave it to me, and so now there's a checkbox there for this that you can check. So if you're worried about your friction rate, you can. It takes like I'm assuming every fitting and your total equivalent length for every run, and breaks it down. And so a lot of times it's giving you, I guess maybe I don't understand it that well, but I'm assuming maybe worst case scenario, but then it tells you what, with the big picture, what you might actually be at. So the way he explained it to me was, if your friction rate is a little bit worrisome, you can use this toggle button to see what it might actually be in the field, and that gives you a little bit more comfort in the design. He said, but don't leave it on because that will lead you to some poor duct design if you're not paying attention or somebody doesn't know what they're doing. But it's not the variable friction rate, it's the total equivalent length. It's actually velocity adjustment of fitting equivalent length. And it's in your duct preferences. And it has to be activated. It doesn't come standard. You have to hit control something and then it pops up.
Because I know in RightSoft there is a box you can check for, and mine's always checked for use adjustable friction rate.
It is.
Talk about
Yeah,
something.
it's always checked. Yeah, I popped it up right after I said that. I was like, is that what that was? And I popped it open. I was like, shit, that's not even what.
And also the thing to remember is that Manual D, those like the total equivalent length or total effective length, I always forget which when you use the word equivalent, when you use effective when I'm talking about these. But it is based on 900 feet per minute through a fitting. So,
right. Well, that's what he said. That was. I'm glad you said that because that was his words. Was that it's based. Everything is based on 900.
Right. That's Manual D. That's not right soft. That's Manual D.
Right. And it's not entirely accurate. So by clicking this box, it then takes your actual duct design and figures it up. And a lot of times it puts your friction rate in a more ideal spot. He said, but don't design it with this selection on. Design it like normal, and then if you're a little worried about it, you can click the box, see what your actual fittings produce, and then you can say you can either thumbs up or thumbs down and redesign it if you need to.
Sounds like they built in an equation to reduce or put in the appropriate equivalent length for fittings and things based on the velocity. They obviously have like a velocity correction factor going on. And
if I knew how to share my screen, I'd show it to you.
Here's my thing with that. Bigger duct's never a bad thing. And you're not going to get crazy amounts of heat gain from having one duct. What that's going to do is maybe adjust some ducts by one size, basically. Okay, so if you're dealing with, let's say you got 10 runs on a system, and you've got 5 ducts that could be reduced from a 7 to a 6. In the whole scheme of things, who cares, right? Like, why do you want to make that slight change? The price is almost irrelevant, and you're going to have a better chance of not having a failure on your hands by running the bigger duct, and you could balance it to perfection. You're not going to get the heat gain on surface area of the duct doesn't even come into play when you're talking about 6s to 7s with 5 runs out of the total install. It's just a mute point. So like I get that feature's there, but that's like really getting into the weeds.
Yeah, which is I think why they hide it. You have to activate it because of exactly what you just said.
Yeah. Personally, it's fun that it's there, but like I would never use it. I just wouldn't. I just couldn't see the benefit.
Right.
Talking about heat gain of ductwork, is that a standard calculation, like a round ballpark, or is that actually calculated per run, so forth and so on?
That's probably a Russ question. I will tell you, I've done a case study on that this past summer on my dad's. My dad has a house behind his house, and I did a full-fledged case study on a AHRI certified system that we installed. Duct leakage was like 20 CFM. I put field piece probes in the attic, and I data logged the attic temperatures, the outdoor temperatures, the indoor temperatures, and the longest run, the shortest run, the medium-sized run, to see what impact attic heat would have on ductwork. And the furthest temperature difference I could get, if I remember right, was either somewhere between 3 to 5 degrees. I don't remember, but it's noticeable in my opinion. 3 to 5 degrees is something noticeable.
Yeah.
From the plenum to the first drop, which was 5 feet, there was literally no temperature drop. To the middle drop, it was like 1 to 2. So in my opinion, when you have and this is like at 130, 135 degree attic when this was going on, the first 10 to 15 feet, you may or may not gain 1.5 degrees. That run that's about 20, 25 feet, that's when you start to see 3 to 5 degrees. And I don't know if that's because the last 10, 15 feet make that much difference, but that's what I noticed during that case study. I still have all that documentation, but it's buried away somewhere and I had to go dig it up.
I've noticed it too. I've gotten myself in situations where I've had to, like Tim said, get rid of some fittings to try, because one, more importantly, I think there were just long runs where we were losing probably 5 degrees in the end. And so we've had to make some adjustments on that, but where our delta was the same, we had a 18 degree delta close to the unit, and then we were losing 5 degrees at the furthest run. So I know it is something that we deal with, but
And I ain't heard no war stories yet, but I'll tell you a fun thing my dad used to tell me. My dad my dad used to say if we, if we ran ductwork and air moved really slow through the system, his belief system was lazy air makes ductwork sweat. How many of y'all have heard that? That was my dad's mentality. Lazy air makes ductwork sweat. Air moves slow. And then I had an engineer later on in my life correct me. And he goes, Chris, he's like, if ductwork sweats because air's not moving, fast through the ductwork, he goes, why doesn't a cooler or a freezer sweat? That air just stays in the box. And I was sitting there thinking, I was like, damn, you make a good point. He's like, because man, velocity, he's like, he goes, it's all about the thermal barrier, right? He goes, that's what you got to wrap your head around. It's all about the thickness of R value and the air tightness. The movement of the air is kind of irrelevant. That was a hard lesson learned. Yeah.
Russ, well, going back to ducting in an attic, what kind of math is involved in there? Because I know what Manual J is kind of evolved over the last few. What do you have to say about that?
Yeah, read section 23 of Manual J, and what you'll find is that it's really, really complicated, but they also take some really, really big assumptions.
Yeah. One of the biggest assumptions in Manual J, I think.
Yeah, it really is. I mean, if you wanted to really nail it down, you would need to know what percent of your leakage is on the return side and what percent is on the supply side. Nobody knows that. I mean, you could guess based on the length of duct, but nobody knows that. And that has a big impact on it. That depends. That affects whether you're pressurizing or depressurizing the house, and nobody knows. So that's a huge assumption. And then where the leaks are and all this other stuff. So it's a really complicated thing. And my philosophy is just do the best you can, do a good design, do a conscientious design, and all those things kind of get hidden away in the
Russ, what section did you say?
23, section 23.
23.
Yep.
I did an
A couple
experiment.
questions.
Go ahead.
I was just basically I was a service tech for like 8 years, and then I started my own business for the last 2 years. So what I did when I was still a service tech, I took ACA's design class, went through the whole Manual D, Manual J thing. The thing I kind of found hard transitioning into that, like doing Manual J, is trying to size things right. Like, am I wasting my time doing like a Manual J if I'm not getting a true infiltration and duct loss test? Like,
You're not
that's the
wasting
thing.
your
Like, I was,
time. No, I
I was,
think there are some purists that look. The more information you can gather and the less assumptions you can make, the more accurate you're going to be.
yeah,
At the end of the day, you're taking, what WAG stands for. It's a wild.
Oh, yes.
You're turning a WAG into a swag by doing it.
yeah.
You're putting a little more science into you're taking a little less assumption, but heck, man, I mean, we can get into the minutia of Manual J's. How do you know behind that wall that's actually R13 and that the installers didn't compress the R value?
Yeah, that's the other thing. Like,
Filled with
you don't know if those are true R values. Like, it's just a little overwhelming sometimes. And like all the houses in my area, like I live in Pennsylvania, and like there's so much different construction around here. It's crazy. Like every house is so different,
Just do the best you can. I'm going to be holding my Manual J class again, probably another month or two. But anything that a Manual J without infiltration is still better than 2-ton, 3-ton, 4-ton.
Yeah.
I mean,
I get that.
for the streets. So I mean, you're not wasting your time doing it.
If I could do one test on a house, like if you ask me, hey Chris, you got 2 minutes, go into this house. You could do a load. What would you do with that load? What would you do? Like if you only had 2 more minutes to spend in that house, I tell you what I would do. And this is something you might have to go research, but I would do the room pressurization checks with a micromanometer, so I could see if I got room pressurization problems. And then I would turn the air conditioner on, shut all the doors, check the main door to outside to see if the house is going negative or super positive, which is going to kind of tell me if I have a dominant duct leakage problem on the return of the supply. It won't tell me if I have balanced leakage, but it could tell me if one's super bad. And that lets me know if Pandora's box needs to be opened. It's not flawless, but for 2 minutes worth of time, it tells me a lot. That's what I'd do if I had 2 minutes on top of a load calc. Then you know, like, if you need to put the brakes on and do further testing.
And if you had 10, 15 minutes, do a blower door, and that test
Yeah.
in the context of a blower door, because you could have a house that doesn't show any dominant duct leakage, but has tons of return or supply duct leakage, but the house is so loose you'll never pick it up with the manometer.
Right.
That's what I was getting ready to say. In reference to with reference to outside, you can have a house that's so damn leaky that you're not going to pick it up because it's making it up so fast.
Yeah.
Right. There's nuances to everything, man.
Oh, yeah.
Every test has a nuance to it.
Yeah, but yeah, I mean, you're right. It'll tell you something, and definitely when you're doing comfort consults, if they're saying, well, this room is always hot, close the door and throw a manometer tube under it. And
That's probably the biggest issue that I see day to day is zonal pressures.
Yep.
Well, in Louisiana,
We also have like, I'm sorry.
no, I was just gonna say we live in central Maine return land, right?
Yeah.
So, and we have the problem with not enough return air paths. So, you got to know your market,
Yeah.
right?
Yeah.
Like if your market is central Maine returns, then you should know what you want to test going in. You should have this feel for, well, you're going to be the king of jumper ducts, basically. Like, and you're going to know that's your move. If you live in the land of oversized furnaces, then you're the man of manual J's and reducing furnace tonnages.
We just have everything where I'm at. That's the problem. We have some ranchers with attic units. Then we have development houses with systems in the basement. And then we have boilers. And it's like, there's just like a million things you need to know in this area. It can be a little tricky.
Yeah, you guys in the central part or either central East Coast or like Midwest, you guys get it all. You get the harsh
Steam
winters, you
boilers
get
and radiant
hot
heat and
summers, you know what humidity is, you got a little bit of everything.
attic units. Yeah, it's
Yeah.
crazy. But it's just stuff.
Yeah. Earl had a question about blower door tests. Do we see a lot of them? Unfortunately, we don't see enough of them. Here in North Carolina, they wanted to put it in the code that just passed, and the Home Builders Association was successful in striking it from the code. So we are still going by either 2009 or 2012 energy code. So, and then there's other states like, I can't remember what southern state, like the deep South, that you were like, okay, yeah, they're not doing blower doors, and it's mandatory. But here in North Carolina, I think it's not. It's got a little bit to do with culture, and it's got a lot to do with how strong the lobbyists are. But we don't get enough of it. Russ is from California; they're ahead of everybody on that stuff. But it's regional. That's why Chris says you got to know your region. Yeah, good question though.
We're seeing a lot more of them recently. We do a lot of production home, track home, and a lot of the stuff that we're talking about, whether it's building performance or whether it's load calculations, that just doesn't get done in that market. But what I've seen is that whenever you are doing the load calculations, blower doors, etc., that gives you a little bit of a grounding to know, like, you're a little bit more confident in the performance of your system. So if you have a calculation and you can test the performance of your system and it meets the calculation, not saying that it may not be a problem with the install or the air conditioner, but that gives you a little bit more confidence to say, like, I don't know if this is necessarily an air conditioning problem. This might be a building problem.
Yep.
Well, then you utilize tools like a blower door, infrared, zonal pressure, things like that. And then you can point out some issues that these builders are experiencing.
Yep.
If they bleed enough and if they have to spend enough money fixing these issues, we've got a fairly large builder here that when we started with them didn't do duct glass, didn't do blower doors, didn't seal elevation changes, didn't do anything. The last 2 years that we've been with them, we pointed out enough issues that we're talking to them in meetings, like even today. They're talking about installing doors, windows, and hanging sheetrock on the ceiling, stopping production, and then running blower doors at this point. So the transformation for some of these contractors, it's huge, but it never would have happened had there not been somebody that stood up and said, I can't fix this with air conditioning. This is not an air conditioning problem. I've checked the load calculation. I've tested the equipment to make sure that it's doing what it's supposed to. I think we need to start looking elsewhere, and here's what I suggest. A lot of the issues of people not seeing the value in these tests, I feel like just come from ignorance, just not knowing it. You know, your ducts are sweating in the attic, that's an AC problem. No, it's a building problem more than likely. It's a ventilation issue. You know, you need a 4 ton in a house that should have 2.5 tons. I don't think it's that the 2.5 ton isn't any good. I think it's that you've got a leaky house and you've got zonal pressure problems and you didn't seal elevation changes and things like that. I think that if you work with them long enough, you start to see that ship start to turn. And so I think, you know, I think that's where you have to start. I know that some of the larger contractors that we work for, they're coming around slowly, albeit, but they are coming around. And every now and then they surprise me after working with them for years. Some of the things that they say, like, hey, we'll hang the sheetrock and run a blower door test halfway through the project. And I'm like, what did you just say? You know, it's the same company that wasn't running blower door tests 2 years ago.
They're not coming around out of the kindness of their heart. They're coming around.
No, they're coming around because they're bleeding money. Yeah.
Because of litigation. And
they're used to being able to throw it on the AC guy, and you know it's the AC guy's fault, and the AC guy is not educated enough to know that this is not really his problem, and so he just can't figure it out.
Oh yeah,
and so there's this ignorant kind of I don't know, and then that creates an argument, and in that argument ends up this AC guy gets fired and this contractor hires somebody else. But the moment that you start solving the problems and you start educating and they see that, well, he said this was the issue, we paid him, right, which is a big part of it. Like, now I'm not warranting this and I'm not working for free, I'm getting paid to do this. They're now bleeding a little bit of money to fix this issue, and their ears start listening a little bit more, you know. And so we've seen some major changes, especially on blower doors, because of stuff like that. But it always takes somebody I did a lot of work for free to prove some of these things before they started paying me to do it, but it was a necessity. I had to, so that at some point they would say, all right, you know, call them in and let's have them go look and take a shot at it, and you know, and we get paid for that stuff now.
Yeah, there's a lot of people who make a pretty good living doing that. Whenever every HVAC design or installation on new construction, when you're working for a builder, should come with a documentation saying this design is based on the following criteria. Like when I do an HVAC design, I mean that's like 70% of my business now is, I mean, I'm not even the installing contractor. I'm doing designs all over the country. So I have zero control over all this stuff, but I have a design criteria worksheet that I get a signature on. And it spells out everything that's going in the duct into the load calculation, the entire design, including what the target ACH is going to be. And it's like, look, if this design does not work, don't call me until I've got a verified blower door test and a measure quick commissioning. And that's my out. You know, they're not doing measure quick. Like, don't call me, tell me this house is not comfortable until you show me a measure quick commissioning. Because how do I know that you guys didn't even commission it correctly? And now I'm going to pay for a new system or a bigger system and so again, that came from sewage flows downhill and the subcontractor is unfortunately at the bottom of the hill. And so when things don't work, the owner yells at the contractor yells at the sub, and the sub is like, well, I guess I missed my load calculation, or I guess I got to rip that 2 ton out, put a 3 ton in. And he doesn't have any tools to prove that's not his fault. And he doesn't have any documentation just to show that, no, that the house just wasn't built right. And so that's what this education ultimately is, protecting ourselves. But I don't understand the resistance to it.
Yeah. Well, we got there through problems that, hey, your AC is not cooling the house. Yeah. And where that would have, you know, those are opportunities. So as long as you're fairly confident and look, I did a good load calculation. I commissioned the system. I've got a measure quick, and that's our first step. So when we do a load calculation and somebody calls and says, hey, I'm not happy with the performance, the first thing we do is a measure quick. So we go in, we ensure that the system is performing like it's supposed to. If it's not, we make the correction. If it is, we go back to the contractor and say, look, I double checked my load calculation. We verified system performance. At this point, on the top of every load calculation I do, whatever their target blower door is like right under their name and address. It says it is the responsibility of the contractor to ensure that this dwelling meets this ACH.
Yep.
And so that's the next step. So there's a process that we've learned to protect ourselves over the last couple of years that we follow every single time. And typically that opportunity comes from somebody pointing the finger at you saying your AC is not working properly. And then you have to be ready and have that process in place to be able to go in and say, actually, no, it is. It is working correctly. And this is what I think we need to do moving forward.
Yep.
Eventually, the customer screams enough that they'll throw some money for you to go do the testing just to make it look like they're doing something. And then lo and behold, you find, 18-foot foyer's not insulated or, whatever the case may be. You look hard enough, you'll find something. Something's going to pop up out. But
well, the next thing that's coming is in-home mold tests are going to open up. The lawyers are going to have a field day with that. And again, sewage flows downhill. So who's going to get blamed for all the mold problems with these leaky envelopes and all that? So yeah, it's going to be. I had a few problems when I was doing Energy Star work. I didn't do any new construction unless it was Energy Star. And even Energy Star lets you dump raw outside air into return plenum. And it was killing us during not even shoulder season. It was killing us on a June morning that was, humid and a bunch of dew on the grass. And we're bringing in outside air and the AC's not running. So I finally, again, I ran too many service calls trying to solve humidity problems that weren't my fault. And Energy Star was like, look, that's proved. You can dump return air all you want into a return plenum. No dehumidifier needed. I just started. It was an offer to client. It was like, look, I'll do this job, but I want to put in a dehumidifier. It's going to be $4,000 extra. And then they would decline it. And then it came with, okay, don't call me when you need when it's humid in the house. It's like the subcontractor has to protect himself, but the subcontractor is usually the last person who has the resources, the experience to know to do that. I mean, most of these subcontractors are just guys like you and me, or guys just starting out doing new construction. They don't know to have a legal document drafted. They don't have $2,000 to pay a lawyer to draft up a legal document for that. They don't know to do that. And then they end up getting stuck with all this because they have less lawyers on their team than the other guys up the food chain have. And that's
No. Yeah, and with all that you were just saying, we're right in the middle of all that. I mean, that's a normal day to us. I won't go too further into that, but yeah, we're dealing with all that stuff right now. Even with the Energy Star, we do a lot of Energy Star houses.
Go to Cody for all your legal needs.
Yeah.
And like the jobs that I'm designing, I'm designing LEED jobs. Now LEED does require a dehumidifier for every space, so that's a good thing. But a lot of this stuff is just Energy Star, and there's nothing. Energy Star allows you to oversize a unit, a single stage unit by 120%, a two-stage unit by 140%, and a variable speed by 160%. I mean, those are tolerances that go way beyond Manual S, and Energy Star is like, yeah, we're fine with it. So just because a house is Energy Star doesn't mean it's energy efficient. Doesn't mean that it's a high performance house is what I mean. It does not. And everybody is ignoring part load performance.
Yeah.
It's only design temperature like a few hours out of the whole summer, and the rest of the time. Now I'm not talking about April and October. I'm talking about a June morning where we've got all the latent load, and I swear, like I'm starting on my designs. I look at the design conditions, ASHRAE design conditions, but the very next thing that I look at is the mean coincidental dehumidification. I can't remember what it is. The next line down, and I look at that, and that's what I size my dehumidifier for, and that's what I'm looking at. I completely decouple it. I'm like, you know what, air conditioning unit, you don't do latent anymore. If you do it, fine, it's a little bonus. but I'm not expecting you to do a darn thing on latent. I am expecting you to just handle sensible, and I'll get a dehumidifier to handle latent because I can't trust you. I can't
Yeah.
trust that a variable speed unit and part load operation is going to have anything less than a 99 sensible heat ratio. It's just
Daikin works
no, they
pretty
don't
good.
publish it. They don't
I like
publish it either. So how can I trust
So,
you?
Yeah.
I can tell you, I mean, I'm not bragging brands, but my Daikin fit in my house.
Right.
I've actually measured it with a true flow at different ranges, and I've watched it maintain the same sensible heat ratio from like a third of capacity all the way to full capacity of like point sensible heat ratio. And this was Measure Quick spitting that number out to me, but I want to say it was like 0.65.
That's pretty
Yeah.
good.
Well, Nate Adams did the
Yeah.
same thing. He did the same thing, and he got the same result. So he had on his podcast, he was talking about the Daikin fit and said that he was blown away.
Yeah,
by,
that thing will suck some moisture out, even at part load. And that's not true across the board, though.
No.
They don't all do that.
Yep.
They'll get a little bit more aggressive on their water removal capacity and low speed. I would say limited experience with Mitsubishi on one of their lines is a little bit. It's crazy because it's not necessarily the brand; it's the unit itself.
Yeah.
Right. There's when you get into the inverters and you start looking at tonnages, one thing you should start paying attention to as you start designing and getting really critical is looking at their submittal sheets. They'll have minimum capacity, right? So like I was designing a job for work we did. It's going to come out. It's going to be a video on it and all that. But anyway, I was trying to decide between a 2-ton and a 2.5 ton. And I want to say the minimum capacity on the 2-ton was going to be maybe like 18,000 BTUs, and then the like 2-ton was going to get down to 13,000 BTUs. Well, that was kind of like a noticeable swing because I was looking at how much runtime would I have in part load condition, and I was looking at my my 1% dew point ranges, which was in this climate was around 70. So I knew I was going to be dealing with moisture, in part low condition. So the decision was it was a decision where I had to say this was the dilemma. If I would have went with the 2.5 ton, it had way more heating capacity. I almost could have had no electric heat needed for this job. That would have been awesome. But I would have gave up my runtime and part load capacity that I needed to get rid of moisture. I wanted to tackle the moisture problem more than the heating problem. So I went with the 2-ton and installed electric heat, and the electric heat is going to stage in when needed. And I had to make that sacrifice because of moisture. And so that
In a
minimum
southern
capacity,
climate,
this was in Virginia.
Virginia. Yeah.
Yeah, and think about northern climates where they have the equivalent of, I don't know, 4 tons of, I know we don't talk about heating in tons, but like you need a 4-ton heat pump to heat your house. Well, you only need a 1.5 ton to cool the house. What do you do? And that's the problem that we're going to run into with all this electrification without proper training, is that they're going to yank out a 2-ton air conditioner and they're going to put in a 4-ton heat pump on a duct system that's not made for a 4-ton heat pump, and on a cooling load that's not made for a 4-ton heat pump. And they're not even going to use a cold weather heat pump, and they're going to it's going to be a disaster. Earl had a question. And we can keep talking about this, but I just wanted to share my screen about how ducting a dehumidifier. You can go on any Santa Fe dehumidifier, the Ultra series, in their manual, they'll show you how to duct it. But like when I design a system, this is one of the details that I make out of CAD. And so, and I always use a Haven to control it. But you're bringing in your return duct, step up to a media filter, coarse air handler. Here's your dehumidifier. Your dehumidifier is going to pull a return. Now, preferably, it's going to have a dedicated return out here, but practically wise, you can't do that all the time. You're going to pull a return. If you can pull it off at a 45-degree angle, remember we talked about T's versus Y's. You can do that if you can. I always put a little bit of flex duct in there for noise and vibration. Make sure you put a backdraft damper in here, because when this blower's off, You don't want the air handler doing this, turning it into a bypass. And then you dump it back. And actually, this needs to be revised. Santa Fe is suggesting that we dump it into a 45-degree angle. Again, this dehumidifier has to fight this static pressure, has to push against it. And the Santa Fe's have a beefy enough blower that can do it. But I can tell you other brands that don't. And so, and a lot of other brands will have you pull from the return and dump back into the return because they know good and well their fan can't overcome the static pressure. So as long as you got a decent static pressure, you're not running like a half inch on the supply side alone. You throw it to a 45-degree angle, it'll mix back in there. But this diagram, Santa Fe gives it, it's got you a diagram on that. Just go by that. And
I've put in a scoop before, right where the supply goes into the supply. I've just mounted like a scoop. That way it's not just deadheading it. It's got almost like a scoop to run out. It's just a cheap, efficient way to avoid all that velocity pressure.
Do you calculate the pressure loss on that fitting when you do your manual D?
That's exactly right.
Tim.
Yeah.
Do you add the CFM from the dehumidifier to your total system? Or do you just dump it?
I haven't. There's not a great way for me to model it in RightSoft. Maybe somebody else is a better.
Well, let me ask you a question. Why would you add? Are you saying you want to add the load to the dehum to the total load?
No, I'm talking CFM.
Would it actually add CFMs to it because you're running it in parallel? So,
well, if my dehumidifier is moving 150 CFM, and I dump that 150 CFM onto my plenum, my system's moving 150 more CFM.
Yep. Yeah, I can see that. I haven't done CFM. I do look at mixing temperature because and that's a good question. I think we should probably
That's a good question.
more of that.
I would ask
Bypassing the blower.
I would ask a couple questions. Like, when are you going to see that install? Are you saying you're going to see it on single stage or mostly non-single stage, mostly inverter, right? And the idea behind a dehum is to not run when the air conditioner is at full tilt.
Well,
right?
the way I install mine, I run the Haven control, and my blower on my dehum's running 24/7.
Yeah. Yep. That'd be an interesting video to make. How, take a true flow grid, quantify your total airflow, and then unplug your DHU and see if it changes.
Now, let me say this. I did do a job a couple of months back running high static, and I didn't do my due diligence on the front end. And she called me back having issues while I installed my dehumidifier. I did increase some of the size of the ductwork. I changed some of the fittings. I took out some pressure boxes and put Ys. So I made some huge improvements to the duct. I installed my dehumidifier with a 45-degree takeoff backflow on the top of the plenum like I always do. She calls me back about a couple months later saying, hey, something's going on. I went back out and I started checking static pressure. This freaking thing was running 1.1. So I started kind of panicking and I'm like, well, what the hell's going on? So one of the things I did, I checked my static pressure with my dehumidifier running and off, and it didn't move.
And your dehum's dedicated air, not pulling from the return air?
Correct. It's a dedicated return. So basically,
what was your supply static running? What was your pressure on your supply static?
let me see. I just freaking had it up.
Could be it wasn't moving enough air because when you're talking about airflow and pressure in a duct, let's just say you're running which doesn't sound like it because you're running 1 inch, but if you're running 0.3, if you add 150 CFMs to that, the ductwork may be so big that 150 CFMs doesn't nudge the pressure.
I didn't check the supply side. I checked between my furnace and my coil, and I was running at 0.6. So right before the coil, which, like you said, I should have checked the supply.
Yeah,
Yeah.
the supply is critical because if you're running a really high supply static, your dehum, it's like hitting a brick wall. And the dehum is trying to force air, but it can't get it in there. So now the dehum is, you bought a 70 pint, you're getting 10 out of it or something, you know.
Yeah.
I mean, that's a whole nother. Are any of y'all going to the symposium, the HVAC school symposium?
By the time I found the freaking tickets were for sale, it
Sold
was
out, yeah.
sold out.
The only way I got in is I'm presenting with Nikki Kruger, because I got in. I figured, all right, I'll wait 2 months before it, then I'll go. So, but yeah, I'm presenting with her, and that's one thing I'm going to talk about is supply static pressure, but also just the fact that we can't size these things based on their nameplate information. Just like a carrier 3-ton ain't 3 tons. All right.
Tim, have you ever read the case study done by Andy Ask on dehums? If you haven't, I'll send it to you.
Well, I've read a few. I just don't recognize the name.
Yeah, he's the guy who basically said if we would go supply to supply for a dehum, and the literature shows, man, like, because your air coming out of your air conditioner when contained in a duct, the humidity is super high, right? Because it's boxed in. And if you send that straight to the dehum can remove moisture like a beast and then puts air right back in the supply. It may go into defrost more, but it's still way, way more efficient. The problem is a dehumidifier will probably sweat. So it's got to be in conditioned space to make that happen. But it's like probably the most efficient way to install a dehumidifier. And he wrote a whole case study on that.
I think
What was
I've
that?
seen, who's the guy? Ryan Marks is like an engineer, used to work for Thermistor. He may have referenced that. I think I've seen it, but yeah, send it on. That's interesting that you would. But now, wait a minute. Now, if you're dumping cold air supply out of your air conditioning supply into a dehum, there's not a lot of humidity left over for the dehum to pull out.
Well, there's it's been a while since I read the article, but there's still moisture in the air. The relative humidity is super
It's
high.
saturated.
90 something. Yeah, you're at like 90 something percent. So
The
that
dew
water
point's super low.
but there's still moisture there, I guess is what I'm saying. So
Yeah.
like you have a better chance of it sticking to the coil, I guess is what he's saying.
The RH
I
is
gotta-
super high.
I got a question here related to that.
Mhm.
What is latent heat? Latent heat is energy, right?
Yeah.
Right.
The structure has a certain amount of sensible and latent energy. What's the difference where I pull it? Whether the system, the AC system removes that energy or the dehumidifier removes the energy. The energy's being removed.
Are you asking what's the best way to do it? Because the air
Well-
conditioner is a better dehumidifier than a dehumidifier. It's more efficient. So anytime you can have your air conditioner be your dehumidifier, that's what you want to do.
Unless you got to run strip heat, then it loses all its.
Hey, right, yeah, unless you're having to do reheat as an option.
So it's my understanding the latent is representative of the water vapor that it's drawing out of the air. That's the energy conversion there. The latent heat of, I guess this wouldn't be a vaporization, but the opposite.
Right. But
Latent.
if you're pulling from a supply duct, there's not as much food for the big dog to eat.
I hear what you're saying. I'm looking for it now. If I can find it, I'll send it your way.
I
I
thought
know
Santa Fe was recommending that recently. That they had moved where they were wanting it ducted in. See if I can find that.
supply to supply. That'd be a first.
I thought, yeah.
Because when you look on a psychrometric chart, your dew point is a lot lower. Yes, your RH is high, but your dehumidifier your RH is not moisture droplets.
Mhm.
Your dew point,
Right.
your grains. I mean, your dew point and grains are the same. They're just opposite sides of the
I follow.
spec chart.
I'm with you. I follow you.
But
Yeah.
any temperature, it then drops that air. It's immediately water coming out of it. There's not a sensible load. It's got to get down before it gets to.
Yeah, I do see that. Yeah.
This gets into an area I'm not familiar with, like the actual hardware function. Can it handle that lower temperature? I don't know.
Going to go
I
into
think
defrost.
Goes way back, but I remember talking to an engineer at Santa Fe quite a long time ago, and he told me that their coils and their fin spacing is different than an air conditioner, and it can handle much colder temperatures before it goes into defrost.
Yeah.
I don't remember the actual numbers, but it can perform better than an air conditioner for longer than an air conditioner.
So here's a question. We all know what happens if we dump a DHU supply into the air handler return. We're dumping hot air on our cooling coil. We kill the capacity of the cooling coil, right? Because coil temperature goes up. We're not doing a lot of work, right? But what if it's a Bosch unit that sees that increased coil temperature and automatically speeds up the compressor, because that's how it speeds up the compressor, is it's trying to maintain a 40 something degree coil. Would that not? I've got a Bosch unit. I just got done repiping my whole dehumidifier, and then it dawned on me in the middle of the night. I'm like, well, I can't do it now, but I want to see what happens. I mean, yeah, the Bosch unit's going to pull more amps, but again, it's sort of the best dehumidifier in the house. So why wouldn't I do it that way? Now, another inverter unit, any other inverter technology, they speed up the compressor based on deviation from set point or superheat or something like that. But the Bosch is like, got a higher suction pressure, don't care why, I'm speeding up my compressor. And so it would just compensate.
And doesn't the air conditioner dehumidify less though in the low load, because you're actually ramping it up when it should be ramped down. So then it might the AC might dehumidify less. I don't know. I'm just throwing it out there.
It seems more of a sensible load, but I mean, my DHU's running anyway.
Yeah. We don't really do much dehumidification up north, so I'm not my strong suit, but I do a lot of Bosch units.
Yeah.
Say that one more time, Tim. You're saying if you do a dehum and pump the supply into the return of the
Yeah. So I turn it into a mixed air temperature, right? I'm dumping in 105 degree air, I'm mixing it with 75 degree air. Depending on the ratio, maybe my entering coil temperature is now 85 degrees, 90 degrees. Well, a typical AC unit is just going to run a higher suction pressure, but my Bosch unit is going to see that higher suction pressure and say, no, you got to bring that back down. And
yeah, but I'm just thinking out loud, that's where my brain's going. If you did that, you'd be displacing some of the recirculated air you could be pulling, because your Bosch unit, let's just say, is only going to move a certain amount of air.
Right.
So if you displace the air you want to pull from your house with hot dehumidified air, then you're attacking sensible load and you're letting go of the moisture you could be pulling from your house from the displaced air that you're bringing in from the dehum.
But my dehum is pulling return also, so wouldn't that cancel it out? And it's dehumidifying it. I mean, that gets into some.
Yeah,
I don't know. It's an interesting thought.
it's an interesting thought.
The Bosch is the only one that reacts like that. Everything else, I get it that it's not going to work. But
Tim, one of the videos or something you posted about reconfiguring your dehumidifier.
Yeah,
You zoned it to where it'll do the attic and the house without communication.
Yeah.
I was wondering, why are you even concerned about the communication between the attic and the house?
Because I'm not convinced that isonine is good for you.
Okay.
And so I'd rather not cut a supply cut a supply duct in my attic. Because then what does that do? Well, it creates a pressure difference. One way or the other, isonine air is getting in my house, whether I suck it through a return or whether I do it through. So I wanted to dehumidify either my house or my attic, but not both.
Like when I do mine, me personally, I don't care. It's going to communicate. I encourage communication. However, I always install a dedicated dehumidifier just for the attic.
Yep. And I'm cheap. So there's that.
Cheap insurance, brother. Buy a freaking $1,500 dehumidifier and throw it in your attic.
Yeah. No, this was more also, this house is my test lab, man. I want to try different ideas that I would not, and I said it in the video, I don't recommend doing this as a contractor until.
Well, that's why I wanted to ask, just to clarify, were you actually concerned about it, or was this just an experiment?
Yeah, I was concerned about it because it's me and my wife here, and I don't want us to develop cancer 20 years from now when we figure out, oh yeah, sorry, it's asbestos all over again. I don't. So who knows? And I mean, look, I've taken some instrumentation up there, and I don't read any VOCs coming off of. I don't read anything off gas and off of it, but. I don't know. I just didn't want to do it. So I just wanted to see whether this was possible and if it would work. The real test is going to be, and the other reason why is I wanted to be able to show people how humid the ridge of a spray foam attic gets.
Yeah.
And
you
so
have a data logger up there?
Well, what it's going to do is I pull when it goes into attic dehumidification mode, I pull a duct from the top of my attic.
Yeah.
So I run it through the Haven. So every day at 2:00 or whenever I tell it to switch over, we're going to see a spike in dew point in Haven, and we're going to see how well it brings it back down. And I'll just let Haven do it.
Speaking of Haven, let's go down that rabbit hole with the ventilation control. Haven's only controlling ventilation when the total VOCs get up. We need something to give us constant ventilation, and then you can give us a spike when VOC spikes.
I know. I'm talking to them about it. The other thing that I've noticed here in my house is my VOCs are fine, but my CO2 is through the roof.
My CO2 has been freaking sky high in my house.
So
Are you doing comparisons based on a different meter? Because
it doesn't read CO2. I've got an air things on here. And what I found out about my Ecobee thermostat, it's not a real CO2 sensor. They're actually converting VOCs to CO2. So the air things, see you, Cody. So yeah, I had to get something that actually read CO2. And I also want something that talked to if this then that, because then I can get a little Wi-Fi relay. So I just texted Kevin yesterday. I was like, dude, you need to get the controller on if this then that, because I can hook up my air things and ventilate to that. And he said it's in the plan for 2024, but it's not their first concern. Yep.
Tester or whatever you want to call it. Because I live literally 100 yards from I-12, the busiest freaking interstate in the South. And I was concerned about carbon monoxide.
Yeah.
So I was expecting carbon monoxide to be through the roof, and I don't have any, which was a freaking surprise. However, what hit me like a slap in the face is the carbon dioxide is through the roof.
Yeah. Yeah. Ours is just because my house is really tight. And
mine isn't. I'm a 7 ACH.
Yeah. Well, speaking of carbon monoxide, this is the first time since I started ventilating to get my CO2 down. I posted this on Jennery's Facebook group. Actually, well, yeah, still reading zero. We've been in this house for almost 6 months, and my carbon monoxide personal monitor always reads 3. I take it outside, it goes right back to 0. And I'm like, we're all electric here. For a good while, we weren't even parking in the garage because we were still moving in. All our crap was in the garage. I'm like, where is it coming from? And it wasn't until I started ventilating more to get my CO2 down, and now I'm at 0. So I don't know what the cause of that is. I don't know if there's something that's off-gassing, that's cross-communicating with the sensor, but all I know is since I started ventilating more because of CO2, I probably ventilate 70% of the time now instead of 10%.
So
it's gone.
What is your thoughts on this? S-Ray 62.2 says I need 50 CFM of ventilation for this particular house. I set up my ventilating dehumidifier with the Haven control, and I manually open that damper to move that 50 CFM continuous and just let the Haven fully open it when it needs the boost. Is that a good...
Yeah, and I like that's Joe Stiebrick says that he thinks that ASHRAE 62.2 is a little bit overkill for continuous ventilation that he suggests maybe continually ventilate half of that, but have the capacity to ventilate up to 3 times of that on demand. And I agree with that. And I've seen that in my own house. Like, I probably should be ventilating a little bit all the time.
Yeah, that's the way I feel about it.
And I'm sorry, it helps pressurize my house. Like, why would I not push moisture and contaminants out of my house doing that? So I would rather, if I had to do it all over again, I would have ran a 10-inch outside air out, and I would have had a 2-position damper, 0, 50, 100, or whatever, like what you're saying. And the Haven would go between 50 and 100, and then it would operate between 0 and 50 anytime pretty much all the time.
I mean, now that I've seen my personal house, the carbon dioxide levels the way they are, like, I want this freaking thing ventilating 24/7, damn near as much as possible.
Yeah.
And we all know the indoor air quality is freaking crap in our houses, so why would we not want to ventilate it as much as possible?
Yeah, I tell you, I've gone full circle on this, because when I was experiencing all those Energy Star house humidity problems, I was like, there's no reason we should be pulling in this much fresh air to a house where, it's like, okay, fine, we're diluting VOCs, but we're creating mold. Well, the answer is we needed more part load dehumidification capability.
Yeah.
And actually, we do need ventilation in house.
But are you allowed to do that in an Energy Star house?
No.
Right.
Haven is not Energy Star approved. They want you to be either, they do not approve ventilation on demand. It either needs to be continuous or it needs to be intermittent, but intermittent like on a timer, not on demand.
Well, if you do an Energy Star house and you go throw a 98H in it, you take a penalty for that, right?
I think so, which is stupid.
Right. It's asinine.
Yeah. That's why I don't. This is what happens when you put energy in front of safety, health, and comfort. This is exactly what happens. It's a war on sensible heat, and you end up making stupid decisions like that. You penalize somebody for moisture control.
My huge argument to all this is controlling moisture. I take controlling moisture of utmost importance over anything else. If you can gain and can control the moisture of the house, you're building a sustainable house there. You're building a house that's healthy for people. It's not going to kill the people in it. You know what I mean?
And you do that by tightening the house and controlling ventilation.
So you'll get the byproduct of that is going to be an energy efficient house.
Yep. But,
you can't have the reverse though.
Right. It doesn't work in reverse.
Right.
You can't put energy in front and expect to get comfort and health and all that stuff. Yeah, they'll penalize you. And that's my whole problem with it. And then when you work in, like, part of what my business does is I review designs for Energy Star and lead jobs, like in the Cincinnati market. And so I look at other guys' Soft deliverables and make sure they're compliant with ACA 310 or Energy Star or LEED, and you're looking for things that they missed. You're looking for, they oversized the unit and that sort of thing. And you see that really the mentality in that whole world is, look, you're going to get your Energy Star certification. We'll fudge the numbers if we have to, but you're going to get it. And it just defeats the whole purpose of having it. So you turn it into a certification mill instead of doing what's supposed to do, which is deliver a better home.
Yeah.
And it's unfortunate, but
that's one thing, Tim. You touched on this earlier in the presentation, but I'm 30 years old and I tried Soft and it just seems so outdated to me, and like it was just a pain to use. I'm serious.
Try Elite, bro.
Yeah, Elite's
it better.
Yeah, I get it. That's why Russ King, he just jumped off of here. He's the founder of Quick Model, or it's Quick Model, right?
Yeah, that's what I need to try because.
Yeah, and
I paid all this money for Soft, and dude, it gave me so many headaches. I'm like, I can't even use this. Like, I'd rather do it manually than use that. But I do my load calcs differently. I actually use Cool Calc, which I do a lot of block loads and retrofits. Like, I don't do a lot of new construction, so I found that's a little easier.
Yep.
Also, Carmel Soft for my iPad is pretty decent.
Yep.
But like, I just feel like HVAC is so behind in technology with all like the apps and our phones and everything. It's just like there's so many great things out there, but I feel like HVAC is just so far behind. Like,
On
Right
every
soft
level,
is
not just load calculations, on every single freaking level.
everything. Yeah. I mean, it's just like our technology, like all like these Wi-Fi thermostats and like Honeywell stuff, like some of it's just so far behind like other home automation systems. And it's like, I don't know why. It's just, I guess it's such a niche, like not enough people even do it for them to invest all this money in it.
I
But
think
I don't know.
I think that's got a lot to do with it. I think it's forever this industry wasn't exactly the super money making industry, and now it's starting to get that way.
I
And
don't know.
I think I've heard that like there, maybe in the United States there's somewhere around 700,000 technicians,
It's
So if
not
you think
enough of a
about that number,
market.
yeah, that market's not really huge, to be honest.
So
I
we're
mean,
stuck. We're
700 sounds
stuck
like
with this
not that many.
stuck with this 90s technology that's just like takes forever. I mean, and then I even got like their Right J Mobile, but like I didn't like that at all. I thought it was like super cheesy. It was hard to like,
Yeah, I tried.
it's because like
It was.
when like I do a lot of swap outs, so like you can't spend forever like kind of doing a block load, So I was trying to make it so I can do a legitimate, but that's like I said, I'm not doing duct leakage. I'm not doing so like I didn't know if I'm just doing a disservice by even doing it.
No, you're not
But
doing
like
a
I don't know.
disservice. Not at all. I mean,
Thing is, too, the more you do it, the more you learn.
No, I got a lot better. I've been doing it for like 2 years now, and from the beginning to now, I can do it a lot more effectively. But it's
yeah.
just I like to do things right, and up like where I live, nobody really. There's not many companies are doing blower door tests and duct leakage. I don't know why, but it's just I feel like in the South, like all these trainings and that symposium, like I feel like you guys, I don't know, just with humidity, I guess, and all the attic duct work, like it feels like you guys are pushing things way more than up here. Like there's nothing up here. It's kind of like a free for all.
It's the
I,
same
I don't
thing
know.
down
think
here, bro.
I think yeah, it's the same thing down here. But I think what's going on is I've watched like who I've met in this role, and I just watch them, man. I look at John Simmelhack and Neil Comparetto, and I'm just like blown away. Like those guys can probably name their price, right? And they when they walk on the job, like that homeowner just knows. I just hired the ultimate best mechanics I'm gonna get, and I'm gonna get one hell of a job. And I don't. I mean, I'm sure it took years for them to get their reputation up there, but if you take that path, man, it's got to be a hell of a good feeling to be those guys right now, to just know like you're the person in the market, people call, when you get the call, what you're walking into, a homeowner who's prepared to pay because you've made that reputation that you are the guy who does things all the way.
Yep. And I say this to a lot of people, and I probably should say it more publicly. But I tell people, let Walmart customers have Walmart companies. There's a reason why Walmart is so big because there's a lot of people that's what they want. But when I buy a pair of dress shoes, I go to a men's clothing store a lot. And when I buy a suit, I'd rather go to a boutique shop because I don't want to buy a suit from a big box store. I'm a discerning customer when I buy a suit. And there are people out there that are discerning customers that want there is a Neil Comparetto customer base in every market. You just got to be the Neil Comparetto. And
Yeah, and
you're not going to grow like the biggest shop in town. And you need to be okay with that. You're going to a lot of people say you're way too expensive. You're out of your mind. You need to be okay with that, but you'll find the people.
There's so many cheap customers, they're looking for
They're
the
everywhere.
lowest price. You don't want that customer. And then if it doesn't work right, you're going to be there a million times.
Right. I can't even speak their language. I mean, people that are okay when their sole decision is, well, how much is my monthly payment going to be? That's where their decision is. I can't even talk to them. Like we're not even on the same plane. Like I don't
Can you
know how to
itemize
talk to
that
the
for me?
financially illiterate. I don't know what they want. I'm not like them. So I don't sell to them. Yeah. Yeah. Good stuff.
there's a lot of people out there who want the quality install, but they have to understand why they want it. And if you hone in the skill set of and I'm not gonna say I was no Neil Comparetto when I was in the trade, but like my last probably 5 years in the trade, I did a pretty good job of making my name in my market. To I wasn't Neil Comparetto, but I had a good name and I could charge a super premium for doing my installs. But they knew when I came in, It was load calculation, blower door, duct leakage test, install, commissioning on the way out. That's what you got. Like that was my turnkey, super whammy bammy thing. And if you didn't want to do it, then sorry.
Yeah.
I don't
What's
care.
like the best path to get into blower door testing and, like BPI certification? Like if I wanted to start pursuing that, like what's the starting point, Because I mean,
I think
I saw the BPI class, yeah,
BPI is probably,
is in the area.
yeah, I think BPI would be a good place to start. Get the blower door basics down, get the total duct leakage testing down. And those two right there, hell of a place to start, right? Once you know those two, that's big. Then, there's some, and if you want a precursor to that, before you go into that, like, here's what I'll tell you. Do you have to go get BPI certified? No. Would it probably help your case selling to the homeowners? Absolutely. If you want something to taste it before you get into that class, like TEC has all of those trainings it will be tool specific, right? It will be our gear, but those, the testing, how the test should be done. We have those videos all on the website. There's a whole training module you can watch on our website.
You can learn how to do it without going to BPI.
I guess that's what I'm saying. I don't want to shed, like, I don't want to say BPI is not important. Like you're not going to go to our website and probably learn combustion safety. Like we're not going to teach that on our website, right? That's not exactly what we're known for. But if you want to know how to run that blower door, like we have videos for that.
Let me say
it's like way more comprehensive.
Let me say this as far as testing, and I know y'all probably going to call me down on this. I'm all for testing. I believe in test in, test out, testing for compliance and whatnot. However, I don't need to do a test and collect a bunch of data for somebody to tell me the sky's blue outside. If you walk up to a duct system that nothing's sealed, you got ducts falling apart, like I'm not going to charge the homeowner $400 to hook a duct tester to this thing to show them your duct's leaking.
Yep.
Yeah. Same thing with a house. I go into a house and I got top plates cracked open, knee walls. You know what I mean? I'm not going to sell a blower door test on that.
Yeah. Right. If it's an ACH 50 of 11, there's no need to go and like you should have a conversation before you do it.
It's just like I have no experience on where these houses really land. Like I took the trainings for ACA and all that, and they say, just you can tell if a house is leaky or not. You know what I mean? It's just common sense, but it's like how leaky, I don't really know. So it's just getting that baseline. I mean, just kind of
err on the side of caution. You can't tell that a house is tight without a blower door test. You can know. You walk into a 1879 farmhouse, it's going to be leaky. You walk into something, you kind of know by the era that the house is built, and that it hasn't been weatherized. You don't see any spray foam anywhere to be seen. It's going to be leaky. So yeah, you're absolutely right. You don't need a blower door to tell them that. But when you do a load calculation, what number do you put?
Yeah, exactly.
So I
mean, I would always
same thing with
I would mess around with it sometimes. I would do semi-loose, then loose, and kind of see what my differences are, and kind of make some decisions that way. But,
yeah, loose is higher than 11. Semi-loose is like 7 to 11 or something.
I'll tell you what Alex Meany says to that, because we've kind of had a little chat about that. And he's like, if I don't have the luxury of maybe getting money for my blower door to do my load calc, I'm always going to select average.
Average, right?
Because it puts you right in the middle.
Puts you right in the middle.
And that way, if you're one-sided, you're only halfway off. Right?
Yep.
I don't know what construction's like in your area, but like, let's just say like your standard like development house built in like the 2000s, let's say R19 walls, 2x6 framing. Like, what would you expect to like? No spray foam, just like your normal R30 attic. Like, what would you expect that to be?
5 to 7.
Like, keep in mind, insulation is not an air barrier, so you can have R30.
The insulation is completely irrelevant in that conversation.
Yeah, it's basically just not sealed, like no spray foam, no, sealing normally around the from my
from my experience with it, I would say the house you just described to me is probably a 5 to 7 ACH 50 house.
Yeah, I'd say 7.
Yeah. And then, when you get into a spray foamed house, it really can get radical, but typically I'm seeing 2 to 4.
That's going to depend on who shot the foam.
That's exactly, well, right. I mean, all of this is just general talk, but foamed
Craftsmanship related. Yeah.
yeah, foamed houses that are nice, 2 to 4. Traditional build houses that with some attention to care, maybe a 4, but probably not. Mostly a 5 to 7. And then houses that didn't get neither, those are wild cards. They could be anywhere from 7 to 13. That's typically what I've seen.
Yeah, I've had a new construction house in Baton Rouge that I tested was like 12 something.
Yeah.
This was a custom home builder.
I mean, I went back behind our framers and I was spray foaming, and I mean, I had to get on them about rolling zip tape on their zip system tape. The typical, I would love to blower door test my next door neighbor. Their house went up at the same time ours, same builder, just a whole lot different approach to the envelope.
Yeah.
And just see, but yeah, I would say 5 to 7 on a new house built to code right now.
I don't understand these builders.
Huh?
I don't understand these builders. They buy the zip, they pay the extra money for it, and they install it just like regular OSB.
Yep.
I'm like, you just negated everything you just.
Yep.
You know what I mean? They have no clue. They like it. It's the green thing to do, and they think they're making a huge difference. They're saving the polar bears, but you piss them in the wind, brother.
My framers framed my front porch overhang with zip, but then they ran out of zips and they used regular OSB for the actual envelope barrier that goes in my attic. And I was like, they were just doing it for looks. It just looks good. It looks green from the street. I mean, they just don't know. That's like one of the lessons that I learned telling the wife. It's like if I had to tell someone else how to do this, is you've got to get a builder that he is a high performance builder. Like he's a stakeholder in this, and if you don't, then you got to be prepared to go above and beyond what you normally would do as an owner to make sure you have an airtight house. And my builder was cool. He was not against it at all. He was just like, look, we build the way we build, but if you want to come in after hours and spray foam all you want, have at it. And he let me do it. And, I love the result of the house. I just have a hard time getting rid of all the CO2 I'm breathing out. But
I have my general contractor's license now, and I'm waiting for Chris to cut me a big check so I can build his house. That'll be my first high performance house.
I hear you.
One day, man. One day. I told him if I ever build a house over here, I'd let him build it and we'll tag team it together.
That's really cool. It was really fun to put into practice some things that I had just freshly learned. I mean, a House Has to Breathe that just came out. I was looking at a lot of Matt Reisinger stuff, trying to sort through what was actually doable on a budget and what wasn't. And in the end, like the biggest bang for the buck I got was zip system and spray foam in the roof deck. Like those are the two things I have.
You didn't buy a Zender?
Do what?
You didn't get you a Zender?
Ventilating dehumidifier, man.
I think I priced a Zender a while back for one of my spec houses that I was planning to build.
Yep.
At $12,000.
Yeah, oh yeah. No, I was designing a house in Texas, and same thing. They were eating up Matt's content, and he was like, "I want a Zender." I'm like, "All right, well, Zender does like their own design, like."
Right.
And I saw the bill, and he sent me an email about a week later. He's like, "Hey, you think you could what's the change order to replace that Zender with a Brone?"
They like the Zender has their own piping.
Yeah.
It's like foam core, styrofoam, glue it together. It's wild, man.
Oh yeah.
I don't know much about it, but
Zender designs them. I think your local AC guy, or whoever you can get to install it, and then Zender comes out and commissions it.
Oh, really?
That's what. Yeah, I'm pretty sure the commissioning's like figured in the price tag. I think.
Yeah. That's
like, what's your guys' opinion on spray foaming? Like, let's just say 60s, 70s, 80s construction, like spray foaming the roof deck there. Is that like a bad idea? I mean, I know they say like it can deteriorate shingles and stuff like that faster.
I don't know. I personally, anytime from what I know okay, about like air pressure, natural movement of airflow in a house. Anytime you can put a lid on something, do it, because then you
Yeah.
stop stack effect flows.
Like
Is
my
stack
house,
effect, is stack effect such an issue where he's at in Pennsylvania?
Oh, if it's
Yeah,
cold,
cold winters. Heck yeah.
oh, that's probably the worst.
Wouldn't it be reversed?
Stack effect in the wintertime, stack effect is up. In the summertime, it's down.
So, I mean, yeah. So if you could put a lid on, so this gets really nerdy, but there's such a thing called the neutral pressure plane, right? Which can, like, as it moves up or down, kind of affects the amount of flow you have from stack effect. But the minute you cap the floor or cap the roof, you drive the neutral pressure plane in the opposite direction and you stop the flow, which stops the infiltration. So if I could spray foam the attic and put a lid on the house, that will drastically kill the stack effect flow, which kills a lot of the infiltration. So I would, any chance I could, foam my roof, I would, or seal it. It doesn't have to be foam, but I get that foam's kind of the easiest traditional method to do it right now.
Yeah, the only caution that I would say, and I don't know how cold it gets there in Pennsylvania, but with cold climate,
10 degrees, 10 degrees.
See, if you're getting sustained cold climates, you could have a cold roof deck, and you could have moisture that develops between the roof deck and the spray foam. So I think a lot of cold climates, they'll put a continuous layer of insulation on the roof, on the outside of the roof deck, so you kind of sandwich it a little bit, and then that has air sealing capabilities also. So I would almost consider, in lieu of spray foam, and maybe rip the shingles off if it's around time to put shingles on, and maybe doing something like a continuous. I mean,
Look up Building Science Corp. Joe Stiebrick's got a lot of articles on that.
Yeah. So I was about to say,
he's in Boston, so he would know.
Yeah,
But
he's the super knowledgeable person on that topic for sure.
But either
Just
way,
with like the electrification, it's like if I'm going to improve, or if I'm going to put heat pumps in these houses, like you got to improve the envelope, or it's a waste of time. I mean,
absolutely.
I do mostly dual fuel because you kind of get the best of both worlds. For at least if they don't want to improve their envelope, I do a lot of Bosch dual fuels, which that was the other thing I wanted to touch on. I don't know, like if you guys looked into their coils at all. But Bosch's coil, if you look at their chart, it's actually pretty crazy. So their 4860 coil, which is supposed to be 4 or 5 ton, the C and D cabinet at 1695 CFM, the D cabinet has a 0.4 static pressure drop. It's 4, and then the C cabinet 4860 at 1589 CFM has a 0.4 static drop. So that coil is 4 passes deep, instead of 2 or 3, it's 4 rows deep. So I couldn't believe the static, the pressure drop on that.
That was a question that I was going to bring up earlier. When you're looking at a fan table and it gives you everything from a 0.1 to a 0.9, are you allowed to design anywheres within that parameter? If you need to hit that 0.9 because I got a coil that's taking up 0.4.
That's where we get into.
It's probably not ideal.
It's not ideal, but I mean, sometimes you're stuck doing it. I mean, for years I heard people saying if you're designing or if your static pressure is over 0.5, you're a hack, and you start adding up coils and media filters.
0.4 coil.
Like I can't do it. I get it, man. I mean, I've seen people that have designed 4 inch of static in these houses in Cincinnati. When I first looked at it, I'm like, ain't no way. And I start looking into it. I'm like, no, they don't have a choice. This unit's in the basement, and it's a skinny little 4-story house, and all the ducts are like shoehorned in between the floors and going up a chase and then shooting across. And you got 370 feet of total effective length. And they didn't.
That's how it is here.
Yeah, and so it's. Man, I don't know what you do there.
I remember Aka Ed had made a video talking about just that. Like he said, if the table goes up to a 0.9, you're allowed to design up to a 0.9.
Yep. Just know that your ECM is probably not going to last very long, and you better put a really deep trap on that coil because it's going to blow through it.
To speak on that, because I've had this conversation a couple of times for sure, is you got to watch the tags. And I've talked to a couple manufacturers about this, and I pray that this comes out and it happens and it takes storm. But like the maximum allowable TESP should be on the tag. And what we're seeing on tags is like rated. Well, rated's not the same thing as maximum allowable TESP. Rated is what it's rated. Like, how did it get rated? It got rated at 0.5. That means AHRI conditions was tested at that. That's what's on the tag. And it's this mentality that means that's the maximum you can run it at, and that's not true. Sometimes the tags might say maximum allowable static is, like 0.5, and that is the case, but sometimes it's not. So you got to watch the literature on the tag. It's not always one of the others.
And I would agree with something that like Allison Bales said is anytime you're putting a 5-ton unit in something, it's probably a bad idea.
Yeah.
Unfortunately, they don't design 5-ton units very well. What are the units that always have to have that plate that you got to screw on so you don't blow water off the coil? It's the 5-ton air handlers. You can't build a big enough 5-ton air handler to correct those problems. It won't fit in an attic. It won't fit, through a door. And so I would say is maybe to the point of if you got 3 tons of coolant load, put a 3-ton system in there and let that dual fuel handle the rest. Maybe your balance point's a little higher. But man, I try to steer away from putting in 5-ton units if I can.
Yeah, like really in our area, like they used to, a lot of these multi-story big houses, they used to just put one system in the basement, and it was just bad. Ductwork was bad. Everything was done by rule of thumb. They weren't doing friction rates. They would just do 0.1, whatever, high static pressure. So they did kind of get smart, and the builders figured out, all right, we'll put 2 systems in the basement, one for the second floor, one for the first floor. So it's gotten better, but you're still dealing with those houses where they finish the basement. You can't access the ductwork. They have a 5-ton. They don't want to spend the money to put in another system. So I'll try to if they put new windows in or updated insulation, that's why Manual J is so important, because then you can, you could downsize them like an AC size or a furnace size and lower your static substantially, oversize your filter, return air base. Like I try to make all those improvements, turning vanes in my return boots, open the supply up. I mean, that's what I try to do, but that's what I'm saying. If I'm not really blower door testing the house, it's hard to trust that. Can I trust that Manual J to drop them down a ton in cooling if they put low E windows in from original construction? You know what I mean? It's that's kind of my challenge at this point, but it's
I would trust Manual J. And the other thing you can do, and we've had a few posts about this recently. I think it was actually John Similak. If you put in an Ecobee thermostat, you can start tracking runtime. And if the unit hasn't died yet, you can maybe that last summer that it's going to be in service, put an Ecobee in there, and it'll tell you what the runtime is on a design day. And you can tell whether that 5-ton unit's oversized or whether this is bstat.io. It's an open source website. You can connect your Ecobee to it, and it gives you so many more insights.
What is it?
bstat.io. I can share my screen real quick and I'll show you mine on it.
So speaking of design temperatures, design days, we've had, Chris, what was it? 100 days?
More than normal.
Well over 100. Where our design conditions 93 degrees.
Yeah.
Yep, I hear that, but here's my argument to that. We can't say days. We have to say hours when we talk about that, because it's not days, it's hours. We see that and we only see it for a moment of time. And as we get in tighter, the construction quality should be better, and when it is, and houses are tighter, once you build up that thermal mass of cooling, when you go into that span of I've exceeded peak load, it shouldn't even matter. You know what I'm saying? Because the thermal mass is built up and the dwell time is going to last long enough to get you through that peak that it shouldn't have an effect. For example, think about all the houses you've done that are foamed. Think about all the houses you've done that are not foamed. do your foam houses call you because they don't keep up? I don't have that problem. Like, well, but you know what I'm saying? Like, but why? Because the house is tight, the thermal mass is in check. They're not leaking air out during peak load and having to replenish it quickly. It's hanging, which means the house stays comfortable. So it's like this all goes back to build tight, keep tight ductwork, and you don't even have to give two craps about we exceeded peak load 100 days by 2 more degrees than normal. None of that will even
Yeah,
matter.
I'm not changing my design temperatures.
Yeah.
I'm just curious, is ACA gonna adjust their 10-year?
ASHRAE does.
They'll have to. Doesn't that? I believe that's ASHRAE data that they go off of every so many years.
ASHRAE does.
ASHRAE's recording all the data, and then after so many years, they basically look at it, and then ACA probably makes a decision based on the ASHRAE literature of recording.
I mean, the thing is, like you said, let's say they do go up a degree,
it won't matter, dude.
right, that's not making a difference.
Have you ever gotten a load and changed it?
Yeah, it's nothing.
Well, I'm about to actually. I'll just going to do it just for the benefit.
It's nothing at all.
I bet you won't see any tonnage equipment changes. I've done this. I've went and changed temperatures and played around with it, and I got no equipment changes on it.
Yeah, I'll share my screen. I got my house pulled up right now.
That question I asked earlier about the duct surface area.
What is that old technology there on the screen?
I know it's like 1988 called. They want their technology back. All right, so wait a minute. Let's first go to the. All right, so here's my load exactly how everything sort of stands. I'm at 1.7 tons. By the way, they normally put a 3.5 ton unit in this house, just so you know. Like if the builder's guide put it in there.
Hold on. Speaking of that, did you show this to the builder?
Yeah, I did.
What do you say?
Sit the builder down and explain all this to him, because he's the one that's gonna that makes the changes.
I know. You know a wall when you see one.
But AJ, what you're not thinking is, man, for somebody to hear this for the first time who's not even in this trade, it will be so much to absorb. He'll never pick it up that way.
Right.
But dude, look, just that in itself, like you're putting 3.5 tons in your houses when all it needs is 2.
Yep. Let's see. I know it's in here. Oh, here we go. All right. So here's my design temperature. You saw we have 1.7 tons. Let's turn the design temperature to, I don't know, 99. How about that? And my wet bulb to, I don't know, 78. Let's just
say 79.
79, sure. Okay. All right. Now let's go back over here. 1.7 to 2 ton.
Yeah, you still.
I mean, that's extreme, dude.
Go back to that, and just that was a pretty high jump on Sensible. Nobody's going to make that jump that fast. Let's take it to where are we at? 91.
Yeah.
Let's just go to 94. I could never see it going.
No, I was being extreme just to kind
Yeah.
I'm just dude. After working with
a tenth of a ton.
That speed at which you're changing this and getting data back is freaking like mind-boggling.
Now look, a tenth of a ton for 3 more degrees, and there's no way you'll make a different equipment selection based on that.
Right. Yeah, now, I do want to show you guys something that really does drive the needle. Let me put this back. That is, what if we were to say, I want, instead of running at 75 degree, let's make it 72 degrees.
Oh, indoor temp?
Yeah. Or actually, let's make it a lot. I don't know if here we go. Let's make it 70 degrees. I mean, I had just as much of a jump there. I went from 1.7 to 1.9 trying to cool the house.
Yeah.
I mean, indoor temperature matters more. You look at even and where it really matters is the extended performance data of the unit, because if the difference between that unit cooling a house to 75 and it having the amount of BTUs and work it takes to pull it down to 72 is huge. I'd rather see a higher outdoor temperature than a higher indoor temperature when it comes to selecting units. But
half my customers,
I really wish
68.
I really wish Connor and Russ would have partnered with Right Soft or Elite.
They wouldn't have had them. I mean, my tech owns Right Soft. I mean, they didn't even want Alex Meany. They didn't even want him getting out training people, man.
So
I can say that.
It's such a pain.
Yeah.
And I don't know. From what I've heard, and maybe you can cut this out of the recording if it needs to.
Sure.
But like Right Soft doesn't really care about us. They have a whole separate game they're playing that's way bigger. They cater to the big builders, to the masses. They have their own business where they're just pumping out loads from them to builders. It's this big game. And from what Alex has told me, it's like we're kind of like a nuisance to the business. They almost wish it would just kind of fall to the wayside and fall off.
Nice.
That's their story from what I've heard.
Yep.
That came from Alex, though, right?
Well, we cannot confirm or deny.
It's got to be true.
I mean, they probably wouldn't even. They'd probably just admit it, man. I mean, they've admitted it by not making constant improvements.
Yeah. Yeah.
Dated, yeah.
Just energy gauge is such a pain in the ass to get that information back and forth like that. It's a pain.
Here's what I'll tell you. I mean, if you go, I don't know this because I've never played with it, but like the MyTech software that works for the builders, it's way more enhanced than what you're playing with, Tim. It's
Really?
like Alex told me, it's got all kind of features. They work on that because it's their bread and butter product. So
Yeah.
it's like there's a whole lot of cool shit on that side
Yeah.
of it.
Honestly, like I use Right Soft because I can print Energy Star reports from it. I can when I'm doing multifamily, I can switch things around, flip, and I've gotten over the hump. But
Yeah.
I would, like I told you at the beginning, like a contractor, like I'd be using Russ's program. And I'll tell you, I think the person's still here. We were talking about doing load calcs for replacements. Look into Conduit Tech because they are a up and coming software company. You use an iPad or an iPhone Pro, you use their app, you scan the house, you enter in some information, it does a load calc for you. They're in beta right
What's it
now.
called?
Conduit Tech. Conduit, like electrical conduit tech. They're in beta right now, but they're working on getting their Manual J certification, but that's not easy to do. Like you got to get all your math worked out. And that's a game changer. So
yeah, I saw your post on that, and that looked pretty cool. Because some of them, like even Caramel Soft, is kind of time consuming because you gotta I don't know, it just takes time. It just takes time. Like Cool Calc's a little faster, but it's also a little more inaccurate because you could like map trace the house, but like it doesn't always work that great, to be honest with you. Like
I'll tell you a cool feature that I hope to see come full circle with Quick Model is when they take like Cubicasa and you scan the house like with like a company kind of like Polycam. You go around the house, you scan it, and then you upload it. And from what I understand, Russ is going to take that and develop a 3D model off of it, so you won't have to
that'd be
draw.
awesome.
Yeah, that would be very.
Like I have a laser measurer and there's an app so you can go around and you can hit that and it's supposed to draw out like a architect, like a plan for you, but it's so glitchy and it doesn't work that well that I just kind of abandon it. But like that kind of concept to me would be the best. You could just go around, beep, 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 beep. It'll have a whole layout of the house.
Cubicasa.
If you haven't tried, I haven't tried Cubicasa, but I've tried Polycam and it's pretty cool.
Cubicasa is freaking awesome. Cubicasa is awesome. I've gotten to where pretty much every call I go on, now I'm not doing service work, so I'm not running 10 calls a day. But every like performance call I'll go on, I'll scan the freaking house real quick while I'm there just for the hell of it.
yeah, I mean
On your phone.
that's what I do with Conduit Tech. I send them the data. And I'll do it spits out the load, then I crank out a load on Right Soft and I send them both. That way they can kind of tweak things. They can see where the differences are. But yeah, like on my comfort consults, and I'd be interested to see what y'all's approach are. My comfort consults include a load calculation, the blower door test, and a measure quick. Like I'm gonna do the load calc on the house. I'm gonna see what the unit's actually doing, and I'm gonna quantify infiltration.
You do this on your first visit.
Well, I sell it. It's a service where I make enough money where it's worth it to me. I'm not giving it away.
My first visit, I'll go in, I charge $350. I'll go in, go over the house visually, I'll do some zonal pressure tests, And whatever I see that I need to dig into a little bit more, if it's the AC, I'll dig into it, walls, whatever. I'm dealing with microbial growth. So I'm doing a zone thermal scan. I'm trying to figure out what's going on with the house. And then on that $350 visit, I'll build a scope of work or more testing if we need to do that.
Yeah. Yeah, because you'll never sell your first job if the first conversation they have with you, you're telling them $1,500.
Right.
So you sort of have to start small somewhere around there, and you know where it's heading. Like if I walk into a house and I pop my head in the attic and I see exposed where I see top plates haven't been spray foamed, and I look at my AC boot and I see it hasn't been sealed, and I look at one plumbing penetration, I see that hasn't been sealed. Sorry, we need to test your envelope. Like and so you're not selling work that doesn't need to be done, but you're also screening them really quick and saying, this is what this costs.
Yeah.
You know, 'cause I am a firm believer that loss leaders are, when you go into a job losing money on it, hoping to sell work. I mean, that's how these companies that tell people they need new equipment and sell the $8.99 service call. I mean, that's their mentality, and I think it's really dangerous for us to get into that. And it's
Even if I get a call, just, hey, come give me a quote on my AC system, $350.
Yep.
I'm not coming to give a free estimate.
Put skin in the game.
Right. If you can't pay me my $350 for me to come spend 2 or 3, 4 hours with you in your house, then you're definitely not going to pay me my $25,000, $30,000 to do the system.
Right. Yeah, and I mean, it will pigeonhole you. You'll never grow like the biggest shop in the world or in the country doing it, but you'll get the customers that actually are serious about it. And so I think that's where people like us that are wanting to do better work, we have to realize that like the masses aren't ready for this level of intellect yet. The masses are still shopping at Walmart, but we're looking for the.
Yeah. Also, I think you got to decide what kind of business do you want.
Right.
Are you building a legacy business where you want it to be that level of, ethical, or are you building a business to sell? Because I mean, let's just be honest, man. It's like, no offense against which way anybody wants to go, but a lot of those decisions get made based on what you want out of life.
Yeah.
I've talked. I don't know Brian Orwell, but I've talked to him briefly, and I know like Brian has the mentality of I want to build a legacy company. He's gotten bigger. He's one of the few that I've seen get big and try to keep his code of ethics up.
Yep. It's hard to do.
It's hard to do.
It takes a unicorn owner to be able to do that. But Brian's also not doing a lot of home performance stuff. I mean, he's a demand business. He's a service call business and a breakdown business, and they do a good job at that, and they got a good reputation. But yeah, I mean, the only way you build the biggest shop in town is you have to sell a lot of units, which means you got to pressure your people to sell a bunch of units, which means you're probably selling units that don't need to be sold.
100%. Yeah.
I mean,
that's
the slippery slope that you're on.
They go in there with mirrors. They pull the limit out and they try to find a microscopic crack in a negative pressure heat exchanger. And like, dude, the amount of high sales companies we have up here is just insane. They're just trying to push new units, and they don't do any. They don't do any manual J's, and they just swap apples for like 20 grand.
Yeah. I don't have a problem if you want to go and give someone options for a new unit because the unit's over 10 years old. Sure, fine. Include it one of your options, but don't lie to them. And if you're going to charge $30,000 for a change out, make it worth it. I mean, change the disconnect out. Pull a decent back, do a decent commissioning, do a blower door and a load calc. Don't go in there and like slice into the plenum and bend it so that it fits the new unit for $30,000 and then claim you're the best company in the area.
Yeah. And no manual J, none of that either.
Right, none of that. I mean, I don't charge Rolls-Royce prices, but do Rolls-Royce work. Don't just say you do.
Yeah. Guys, I'm going to jump.
Yeah, me too.
Appreciate everything, guys.
Cool. All right. Well, I'll work on this recording here. It's probably going to take a bit, but yeah, good talking with you guys.
Thanks for all the tips.
Right. Thank you, Chris.
Thanks, guys.
All right.
Yeah.